Hello and welcome back to a new Unreal Engine 5 video here on the Ludwig Fusel channel. Time is a mysterious thing, and for those who can control the time, they have the power over the world. Because, yeah, if you make a mistake, you could just, if you control the time, revert the time and solve that mistake. And that's exactly what is the video game Life is Strange is all about. The game Life is Strange is about a girl called Max or Maxine, and she finds out that she has the ability to control the time. And what I always wondered when playing these games and afterwards and every time I think about the game is, how did they implement that? And I've obviously come up with an idea how you could implement this, and this is what we're going to show in this series of videos. So we're going to implement the time power from Life is Strange.
Chloe, there's something I have to tell you. I discovered I could reverse time.
You don't know who you're messing around with!
Psycho! No!
You can rewind time, Max. That's insane.
This feels like the end of the world.
One quick disclaimer before we get started is that I have not worked on Life is Strange. I don't know how they did it. I have not researched anything on the code base or tried to find out how they implemented this. This is my own approach. It's completely detached from how they did it. But what I suspect is that they've done a similar system, but not, of course, exactly what I've done. So let's get first started by creating a new project in Unreal Engine. I'm, of course, going to use a blank C++ template for desktop and maximum quality. And the name is going to be... I'm just going to call it Time Power, because this is just about the power of time. So let's create a project, and I'm going to see you on the other side when the project was been created by Unreal. Alright, here we go. We have our Unreal Engine project up and running, and of course also have the Visual Studio solution that is currently being scanned by Visual Assist. We're going to let it a bit of time. I'm already going to open up the default game mode that has been created and to quickly check that everything is good, and to also zoom in so that you can see it. I think we get it 300%. Yeah, I think it's good. To zoom in so that you can read this a bit more clear. And here we go. This is like the game base. So what would be the naive implementation for the time power? Well, the naive implementation would just be create some actors and try to reverse the time going to pass to tick. So if you remember the tick function of each Unreal Engine object, actor, whatever, each Unreal Engine object that can be ticked, each actor that can be ticked, is going to get a time on a tick. And you could just say, all right, if I want to reverse the time, like the power is in Life is Strange, you would press the key to reverse the time, and the time would go back, and you would just feed negative values in the tick function and everything would be good, right? No, not as simple as that. Would be too good if this would be possible. I'm not even sure if Unreal Engine actually supports reversing time, not because it probably does not support this because of several reasons. Well, time is not deterministic in Unreal Engine, or at least it's actually not deterministic at all, not in the manner of going forward, not in the manner of going backward. It's not deterministic. It could go everywhere. So by default, if you're doing nothing with your game, so you just use a tick function, time is deterministic. Objects just move around in a sine wave like we had it. They just move around back and forth, back and forth. Okay, it's all deterministic. We can reverse the time. We just plug in a negative value in the delta time, and problem solved. The object is now moving backwards, and we can reverse the time. But this just works for these deterministic simulations. But the issue is that we have some non-deterministic simulation, because the player can interact with the world. The player can press keys, the player can move around, the player can cause other people to move around in a game, for example, or in Life is Strange, interact with objects, take objects away, put them in different rooms, maybe smash a window, and you all need to reverse that. But it's not deterministic, because how does smashing a window work? Well, we have the actor that represents the window. As soon as you throw a stone, a collision is detected and the window will scatter. But this is all handled by events. So the event is basically the stone hit at that window, then the event is fired, and it's kind of like setting a variable, window should scatter to true, and on the next tick, for example. It's gonna do all the simulation and maybe load pre-baked simulation, whatever, and handle all that window scattering with audio playback and. How would you want to reverse that? You need to explicitly implement this. You would need to kind of like have two functions, a scatter window or a destroy window and a repair window function. The repair window function, you would need to take your static animation of the window being kind of like scattered and destroyed. You would need to take this and play this back reverse. You would also need an audio file that is a reverse of the audio file destroying the window, and you would need to play this. So there is some logic involved, and depending on which object we implement, the logic is going to be different. If we have a button, it's maybe quite simple to just pop it out instead of popping it in. Of course, if you have sound, it's going to be a bit more complicated. If you have doors, you can also just move them the other way around. But it is like all non-deterministic. We cannot really determine that because it is driven by events. The event scatter window is hit. And then the window is going to be scattered and it's going to stay in that state until somebody calls repair window. But when should you call repair window? We need to kind of like keep track when events happened. And this is one key element. The first key element is that we need to implement all the reverse timings on our own. We need to kind of like implement the function. We need to implement a reverse action for each forward action that we do. So if we have a door, it's maybe quite easy because the door can be opened and closed. So we don't need to implement something special. But if we have like a window that needs to be scattered, we of course need to implement this in two ways. So first of all, the scattering, and then the kind of like repairing, where the pieces are flying back in the positions where they should go, and then play the audio reverse. So the door, it's probably the same sound for opening and closing, or you have two sounds that are already in place. But on a window, it's a complete different thing. You need to implement two things on your own. This is the first thing that we need to handle. And the second thing that we need to handle is actually the management of time. Actually, three things that we need to handle. The management of time. Each object needs to keep track of all states that it does. So on a door, it's maybe quite simple. The door has only a few states. So it just maybe needs to remember, depending on how often you allow a door to be open and closed in the time, you might want to say in the worst case, yeah, the player is going to open up the door. And in, for example, if the opening of the door and closing of the door takes like 1 second, then you can reverse the time for like, say, let's say 30 seconds, then you would have like 60 events that gonna fit into that. So you need to keep track in the worst case of 60 events. Or you're just gonna say, well, if the player opens and closes the door that many times, I'm gonna ditch that. I just gonna store the first one and the last one, and I'm gonna drop events in between. So you can go wherever you want. You could like say, okay, if the buffer of 20 door open and closes overflows, I'm just gonna always replace the last state. And then if I replay this back, because the reversing time is faster, because you of course don't wanna, if you have something that was really long, you just wanna reverse it very fast, and it's gonna be resetted to the like initial state, and it's gonna go quite fast, the reversing actually. And you might want to just implement this very, very simply and just allow maybe 20 to opens and closing of doors. But the thing is, you need to of course keep track of what happened. I'm not quite sure, but I think dialogues in Life of Strange, you wouldn't really reverse the dialogue. You would just kind of like restore the state before the dialogue. So kind of like you keep like a change what influence the dialogue had, because Life of Strange is a story-driven game. We can actually decide how the different pieces of the stories are gonna end up. You can kind of like, if you make a decision there, then one character might be alive or dead, depending on your decisions. And of course, the ending is also dependent on your decisions, and these decisions are kind of like recorded in your save game, how you decided. And basically, if you have a character and you do a dialogue with him, and you kind of like influence the story, and what you would need to do there is you kind of like need to make a capture before that and after that talk, or you keep track of each decision during the talk, and you have an option to roll back these decisions, and then you kind of like just need to implement these. So it's not always a matter of really exactly redoing all the steps you did. So it's more like of an abstract point of view. You need to have kind of like just keep track of types of change, and this is kind of like the most difficult thing to do in this case, because you don't want to implement this every time again for each actor or actor type you have. So you kind of like want to have a uniform way of storing these changes, maybe as special structs and template instantiations of a given base class that can be basically used to also interpolate between these things by a given function or something like that. So there is like a very high degree of freedom how we can implement this, but we need some way to store these changes. Important thing. So we need to be able to revert changes by having functions in each direction, like destroy window, repair window, and we need to be able to store these changes. And now the last thing that needs to come in place, we need to broadcast if this time reversal starts. So we actually have 3 parts to that whole story. We need to have an inverse of each function that we want to be able to reverse. So actually everything that you have in the game, every interactable thing needs to be reversible to a certain point of degree. Of course, the time power is not really like infinite. So if you might have the sequence in a certain building and you do not reverse, or you kind of like leave this building, then the changes might be permanent. You can say, okay, now I can ditch these. Okay, let's unload all the history that was done. This is kind of like done. This piece of level is done. We don't need to reverse anything there again. So there's always a limitation to that, but the limitation, the sky is the limit. You're going to decide how you're going to implement this for your game. So we have these reversible actions. We need to have a version to store them in a chronological order that we can reverse. So basically say, okay, now the time is running backwards. Give me the changes that were done in the reverse tick, kind of like. If we have the reverse tick, we can kind of like say, okay, did we had any changes for that now reversing tick? And then we can say yes, no, and if yes, we're going to return the change, and then we can react to it. But we're going to get to this in the future. And last thing, of course, broadcasting these events to all actors in the scene, or all actors that depend on that. But yeah, this is quite a lot of to do. But what we need to do first, before we can do all that fancy stuff, is we need to actually implement actions that we can reverse. So we of course need a way to have a framework in there. And since all of these actions are kind of like need to be player interactable, maybe not, maybe we're gonna also have some static things that can be reversed, probably to show this to you. Maybe we're gonna have some train that's running around in circles. This might be something that we can easily start with, so like a toy train, and we're just gonna invert that the train is going backwards. So something like that. We're probably gonna have something like that as well. So we need to basically have a few actions that are running, and yeah. I think this is where we're actually going to start. We're going to implement a few things. And actually, as you know, I'm a big fan of moving statues, so this is actually going to be the thing that we do. We're going to make a statue that's going to move around in circles on this table. Actually, the statue is bad because you cannot really determine the direction this is moving. A train would be more nice. So we're going to try out to do this. So I think this is going to be okay for blueprints. So let's create a new folder here, my blueprints, and let's create this reversible or reversible, I'm not able to type, reversible actors, so something like that. Okay, no, this is not the naming scheme of Unreal Engine, that is the naming scheme of Unreal Engine. Reversible actors, and let's maybe now create an actor here, and the actor is gonna, oh, they fixed that, that is nice. Did they watch my videos? Nobody knows. Probably not. Okay, so blueprint, I'm just gonna call them all ref at the beginning, BP ref, because reversible, BP ref train. Let's call this just like that, and it's gonna be quite easy. Okay, let's open up this blueprint, let's stock it in here, and let's try to do something. Well, what I do want to do, I have this default scene root. Let's maybe add a, let's let an error component, because I really love the error component, and this is gonna be our how I want to call this. I want to call this TPOS for train position. And let me quickly, boom, rotate this around here so that it stands as is. And then I'm just going to offset this somewhere to here. And now if I would go to the default scene root, okay, yeah, we're just going to apply the rotation to the actor itself. So what I now want to do here is, let me actually add something, and let's add a cube. Okay, so we want to have the cube here, and it's going to spawn this here at the relative location, but I actually don't want to have this. Let's also remove, why does there rotation in here? We don't need anyone. So just going to spawn cube here, and let's maybe now scale this a bit down, maybe 0.2, 0.2, 0.2, but maybe a bit longer because we want to do a train. So we have this something like that, and let's also move this up a bit so that the train is not inside the table. Then we have kind of like one part of the train, and now what I want to do is actually duplicate this one to some multiple cubes, so 3 of them. We're gonna can put one on top and one on bottom, maybe something like that. Okay, actually not that far away. And then just to give it more of the train style, it's gonna look really ugly. I'm just gonna give it a bit of rotation. How many degrees did I take here? 30 and then minus 30. Okay, it just fits. Maybe something like that. And that, I know that this is ugly and not proper modeling style, but it should be sufficient. And now I also want to add, maybe, let's add, what do we have? We have probably a sphere that just, okay, no, we're going to do a point light. Because a point light is nice, let's call this train light. So because the train is going to have a light. And what is a cube of interest? The cube 1 is the first one. So let's add this to the cube 1. And let's now give this a location of 0. And now maybe move this to the top of the train, to the front, I mean, sorry. And let's see. I think this is good. And now let's make this green, this train light. Where can I change the color? Here. So I just want to make this very greenish. Okay, the color picker is a bit off screen, but this looks good. So let's make this green. And let's maybe also scale the intensity way down. 1000 maybe, and attenuation radius 20 maybe. How does it look like? I think it should be good to just see it. Just gonna duplicate that train light again, and then I'm gonna put this to the last cube, and then we're gonna have a red light at the end of the train. I mean, this is not really like how you would do a train with green and red lights, but as you can see, they are already getting nicely yellowed together. Just want to have it differentiatable, which is like the side of the train, by having a bit of fanciness in there. Alright, so this is going to be the train. Now let's maybe write some code here. In the tick event, we just want to rotate this. So come on, can I not remove that pin here? Yeah, there we go. So I want to set actor rotation. So I want to rotate the actor. Okay, it seems like I am a bit stupid to do rotation in blueprints, but I found an example. So add actor local rotation is it called, because you want to rotate locally, and then we want to multiply here. That works because that rotator can actually not multiply. And we want to multiply this with a static value, so let's maybe just put 1 in here for now, because we need to, of course, scale this by the second. And then we want to actually make a rotator. And we not want, I think it is it yaw? I hate these pitch, yaw, and roll. I know why can I not really do rotation in the coordinate system? Why do you always need to complicate this with pitch, yaw, and roll? So we want to do yaw. Okay. Come on, break this up. Yaw. So we want to yaw that, and we get a rotator, and we can use this rotator here. So that looks good, hopefully. So let's see if that does what it does. If I would now try to replace the statue by my rotating train. Let's see. Okay, it's maybe a bit too big, but we can solve that without any issue. Let's first see that we get it in place. Yeah. As you can see, this needs to be going to the center. And then let's maybe scale this. Is that uniform? No, of course not. But I think I need to lock this. Was it right? 0.5? Yeah, something like that. Now if I go in here, yeah, as you can see, this now rotates. It's, however, not very cooperative in rotating. It's just a bit too slow. I could like make this. Okay, let's do this in a proper variable. Let's call this one. This is going to be a float. Float. Here. Let's call this rotation speed. Instance editable. Means that we can edit this per instance. And now let's get the rotation speed and just plunk it in there. And the default value is going to be something about... How can I set a default value? Category, yeah, I know what this is. But was it not able? Ah, yeah, okay, we need to compile it before we can set it. Okay, so let's maybe make this at 20 rotation with speed. And now this should, in theory, be automatically all there. Rotation speed? No, is it not? How could I do this? Asset actions, reload. Did that solve that? Yeah, now we have it, rotation speed. Okay, so we have this at 20. This should make this train go. So we have, okay, it's actually gonna go backwards. You can see the green light is now, it's going like backwards than I imagined. Oh, wait. So let's go out of here and let's try to maybe, can we multiply this? Is it possible to really do this? Like, is it possible? It would be really nice. Yeah, the blueprints do have advantages, but still a bit too slow for my taste, so 50. We want to have a nice train that moves around. Alright, so we have our first action that we want to be able to revert. And this is actually all good for now, because the systems that we're going to need to implement are not trivial. So for now, this is going to be sufficient. We are going to go and implement a proper actor that is like interactable as well. Because, well, time reversing does need a bit of time. Actually, we can already implement this, and by having that one, it's actually already quite easy. So basically, when we want to revert the time, we just need to set that value to 1. Or to bigger than 1. So probably it's going to be like -1, the default speed. Okay, it's still going to be -1, so we're going to have another input because this is like all inverted, and by default, if we would want to have 1 here, it should go forward because 1 means forward, and then if we go backward, we would have something like this is basically the initial state, which should move that forward, yeah. And then when we revert time, which is maybe at 2 or 3 times the speed, this would be set it to -3, or better to say a value that is determined by a system, and then you would see it would invert itself. So now we would kind of like roll back time. And this is like deterministic. This is why we can do this as easy as that, and this is kind of like not fulfilling all of our criteria that we specified, or I specified for you at the beginning of the video, but it is like a good step in the right directions to see the basic systems basically getting into touch with each other and being able to be controlled. Let's maybe create a folder here in my scene hierarchy if it likes to do that. Hello? Do I need to do this like that? Alright, let's call this ref objects for revertible objects. Just put them in here so that I can properly group them together. Okay, so revertible objects, done. Now we need to implement a few systems. The first system that we're going to, of course, implement in C++ is going to be our manager class. This is going to be a global actor that is going to be spawned in our scene. That is kind of like our time manager. And that's how we're going to call it. So let's create a new C++ class, right? Where are you? Okay, so tools, new C++. Okay, that is not fixed. That is bad. I hate you, Epic. You know that from my tutorial series, so should be good if I do this without you noticing. So what we're gonna do is we're gonna create a plain actor, and this actor is gonna get the name Time Manager. Time Manager. Okay, like that. Create class, and while it's then gonna recompile that shit, you can already zoom in a bit. I don't know why they didn't manage to fix that. I thought they did, but yeah. Alright, so now we have our time manager, and the nice thing is our time manager does not depend on time. So we don't need to take... This is something that, you know, say, wait a minute, what? It does not depend on time? Yes, our time manager actually is not aware of time. It's just aware of managing the time, right? Even this sounds like super stupid what I said, but it is as it is, so we don't need this. I think as far as I know, we don't even need to begin play. The time manager is a very, very static class. Alright, so the first thing that we want to declare is a U function if my visual assist is cooperative. And I haven't actually used Unreal Engine for a hell of a lot of time, so I do need to reference all of that while we go. And let's create a function that's going to be called get time factor. That is going to give us the current factor of time and return this as a float. It's going to be public because, yeah. This is going to be blueprint callable because we want to make this callable. Do we need some more properties here? Sealed event? No. I think it's actually good. There something that we needed to add always that it works. Don't think so. I think just blueprint callable is enough. So get time factor. If we do have a get time factor, we need to store this somehow. So we're gonna have a float current time factor. Just gonna be at 1 because by default I just want to have it at 1. So this is the current active factor of time. Alright, so we do want to have this as a U property because we might instantiate this class with blueprints. And the U property is going to be blueprint read only because the C++ code is going to write that the blueprint should not write to this. This is a property read only for blueprints. Then what we want to have is a few programmable parameters, which is going to be the normal time factor. It's going to start at 1. And the reverse time factor. Reverse time factor is just going to be something like -1. And both of these are going to be your properties, which are going to be blueprint read write. Blueprint read write. Blueprint read write. And these are going to be our magic time values. So we're going to have the normal and the reverse time factors. And these factors are going to be set accordingly on how stuff is called. So this already helps us implementing the get time function. Come on. Implement. So create implementation is just going to be a return current time factor. Very simple. So these are first steps. That we need to do and to need to reference to be able to properly handle time. And before we're going to get any further, I am going to implement this as is. The only thing that I want to do is at begin play, I just want to apply normal time. So the current time factor is going to be equal to the normal time factor so that we load this at begin kind of like. Okay, so let's see if this already works. So if I lost all my Unreal Engine skills a few weeks, I didn't do a month. Okay, blueprint read only should not be used on private. Is that really? Do I need to have them on protected? I'm not quite sure if I need them at protected or public. If it is read write, it's probably kind of like public. But we're going to try protected first. Let's see how this works. This is something that I always am getting a bit confused. Yeah, okay, so it just needs to be protected. Okay, so now we have a time manager. And we kind of like need to reference this time manager in here. So what I do want to have is a reference to time manager. Can I do this? Time manager. Okay, time manager. We do want to have an object reference. Or what is the soft? Okay, no. We want to have an object reference to a time manager. So we're going to call this active time manager. So this is going to be the time manager that is being controlling this actor. So what we want to do is we want to get this active time manager and we want to get... How did I call the function? I love it that I can't remember shit. Get time factor. So get time factor. Call function get time factor. And this is what I want to do right here. So before I'm going to set the location, I do quickly want to get the time factor. Let's refactor this a bit so this is a bit nicer. And let's try to rearrange them. -1. You go there. And you go there to have this a bit more well structured here. So let's try to, can I move that? Yeah. So let's try to make this a bit nicely structured out. So this is gonna be the computations that we need to do here. So we take the rotation speed, -1, and then we're gonna make rotation from that. And this should now have the exact same effect than what we had before. Okay, it does not. Why is it not moving? Okay. Yeah, of course, we need to assign the time manager. This is important. So, okay. We need to make this instance editable. Editable. Okay, so now we can select the time manager, but of course we need the time manager. So let's get an instance of the time manager up in our scene. Maybe put this into the ref objects. Here's the time manager, and then I should be able to drag this. Okay, no, I'm not able to drag this in here, but I'm able to select the time manager 2 here. Why is it called time manager 2? Let's call this main time manager. Main time manager should still reference that. And if we now run this, okay, you can see it is moving around as it should. So moving around, time manager giving us the correct time. Now, now we need to tell it when to start reversing the time. And, well, it is a power of the character, so we sadly need to create a character for that. So let's go into our content, and let's maybe create a new blueprint class, and we're going to select a character here, and we call this BP character. Okay, done. As easy as that. Save that, or open this up first. We're going to save it, and as far as I know, this should be now no issue to be selected, but for that we need to of course have a game mode. So let's create a game mode based on our time power game mode base. So let's create this, call this one the BP game mode, so our blueprint type over our C++ game mode that we're probably gonna use at some point. So now we have the game mode and the character. Now if we have that game mode selected, we can select our default pawn, and this is going to be our BP character, and with that in place we should have a character that does nothing. Good. But it's okay because it probably does not have anything in here. For that we need to create input mappings. Project settings are already open. If you don't have them, edit project settings. I'm going to go to import down here. And I'm going to do a few axis mappings. We're going to have move forward, FVD. So let's make it a W key here for forward and a S key for backward. Let's create another one. Let's call this move, I think it was left, move left, or was it right? I'm not quite sure. I think left. Let's do A, and let's do D, -1. We don't need gamepad for now. I just want to have some basic moving in here first. So forward left, and now we should be able to get the come on, close the move forward event, and we should also have the move left event. These are like automatically created because we are now using blueprints. I'm not stuck on C++ and Unreal Engine. I am using C++ for the features that I like it, but for something simple as that, I'm going to use blueprints because this is just a very basic character that just needs to be able to move around, right? Okay, then we're gonna add movement input, and the scale is gonna be that one, and we're gonna get forward vector, a capsule component. Is it? Can I not just call this globally? Probably. And you need to go here. So I want to move forward in case of that. Let's make this also well structured. There we go. This one needs to... Okay, this is going to be outside, so they're going to go here, and we need another one there so that it is all nicely organized. Move left is going to be exactly the same, but with a few exceptions. Let's first move that one up, and let's get them in place as well. And instead of getting the forward vector, I'm going to get the left vector. Okay, was it the right vector? All right, it was the right vector. Amazing. Now I did this completely wrong again, so I need to change this, sadly. Move right. So DA, like that, and then this is not probably be there. Interestingly that it's still... What did I do now? Okay, I just closed it up. Move left should now no longer be possible, but move right event should be in here. Good, let's connect them up here. Okay, so now we should have basic movement. Let's compile and we have an error. Is it not possible to get our scene component? Okay, get right vector. Is it that one? Let's see. Get forward vector. Get actor forward vector. That is probably the thing that we care. So we should also have this get actor right vector, right? No, this should be maybe also one step down. Okay, this works, so let's test this out if this works. Alright, yeah, we can move forward, left, but mouse is not working. I do want to have a mouse, not Windows, that one, hit the wrong key. So let's add another action. We're gonna call this look around. And we're gonna, okay, we need to have this at mouse, and we need to have this at the mouse X. And let's add another one, look up. Gonna have this at mouse Y, and now we have a look around and look up. And let's see how the function was called. I think it was called at controller, yeah, at controller yaw and pitch. Yaw is rotation, so look around. I remembered that now. And let's get this as move look around. The look around event, and this is just gonna connect up here at controller yaw, and then let's do this again. But now what is that other thing? Yaw, pitch roll yaw. So what we also want to do is we want to do, yeah, of course I get like German. I Google English but get German. Nobody likes that. The other one is pitch. Okay, so add controller pitch import, and this is not look around, this is look up. So event look up, it's going to be connected here, and this should conclude our simple minimalistic character. Alright, so Y is inverted. I know that that is always what they do. So -1 here should fix that. Yeah. Alright, so now we have, let's quickly check if we're still moving. Yeah. So moving is working without any issues. We don't need any jump, crouching, or any other fancy stuff. We need our time reversal power. How do we gonna do this? We need another key. So back in the project settings, I'm now gonna go to action mappings, add one. This new action mapping is gonna called reverse time. And that value is going to be the control, left control, and I maybe lied to you, maybe we do need to tick at the time manager, but we're going to see, no, we can do this at the character. This is more a character. The character is the one that is actually responsible of how long he can reverse time and what the delay between reversing the time is, but for now we're just going to have it infinity anyways, but this is something that the controller, the character does, so it is kind of like a character property and not a time manager property. All good. Okay, so left control is going to be our reverse time. So how would we need to implement this? Well, we need another event. Let's maybe, can we add there a group, collapse to nodes, alignment, collapse to macro, create comment? Yeah, that is what I want. And this comment is just going to be, this is our default. Can I type there? Yeah, default movement, like that. Okay, so now we're going to do the fancy stuff. So how did I call this? Time reverse. Yeah, action events reverse time. And we have a pressed and released for reverse time. So now we just need to hook them up, press and release. And we need to hook them up to our time manager. So our time manager needs to be able of enabling and disabling reversing. So we need a U function, blueprint callable, void, begin time reverse, And we need another U function, blueprint, callable, and time reverse. And the implementation of them is going to be quite simple, but we're going to call them time reverse control. Time reverse control. Let's just call them control. So that is very simple. We now just need to add an implementation here. So let's start with the begin and the end. Okay, now we have the bodies in here. So what does the begin? It's gonna just quickly set the current time factor to the reverse time factor, because now we are beginning the reversing, and here we are gonna, by ending, setting it to the normal time factor. So very simple, begin and just assigning some stupid values. Going into the Unreal Engine and hitting the live coding button should quickly recompile this, hopefully without crashing, but we know that the Unreal Engine likes to do this, but we since just changed the implementation, so this should not result in any crashes or anything like that. Alright, so changed. Now what we just need to do is we need to add it as a variable to the character as well, so let's create this one as how this is gonna be. Yeah, we're gonna see how we can do this. This is not as straightforward as we might do. I might need to check this on the documentation quickly how I can do this. But let's add the time manager here, and we want to have an object reference, and we're just going to call this time manager. Okay. And then what I want to do is I want to quickly get the time manager, and what I want to do here is I want to begin time reverse, add pressed, and end time reverse on release. As simple as it is. That should be everything that we need to actually trigger our event. So let's create a comment block here for that section, and let's call this, that one is not in line, let's call this time power. So everything that we need for time power. Seems straightforward and simple, but this is going to fail. Because if I click this, it's not going to do anything, and if I would take a look at the output log, you can see exist non trying to read property whatever. Doesn't work. Why? Because we need to set this on a per instance, but we have an issue actually. The character is existing here, and I could now go in here and probably, oh no, this needs to be instance editable, of course. If I don't have this instance editable, this doesn't work. So let's quickly go in here. Yeah, that's okay. Make this instance editable and compile this again, say start. And if I now, it doesn't work still. So if I would go out here and go to the BP character now, I should have this time manager class, and I should be able to select this here while it's running. And now if I would hit the control button, you already saw it, the train goes backward, and if I hit it, let it go, it's gonna continue on where it was. So it goes backward and then it continues on. We are kind of like reversing the time here. But we need to, of course, set this time manager dynamically, and let's actually try to figure out how we can do this. Basically what we need to do here, can we dismiss this? No, we cannot, sadly. We need to kind of like set this on the character, but we cannot because the character is not in existence here. So you can see the player start is in there somewhere, but actually the character not. The character's not in our scene by default. It's been spawned by the it's gonna be spawned by the game mode. But what we could try to do, this is just a very quick hack. We could open up the blueprint game mode. And what we could do is at the event graph, at the event begin play, we could get our player pawn, or player character even maybe. And we would cast to BP character. So to get the proper instance. And then we could set the time manager to a specific object. Now, to which object do we want to do this? So we maybe get the world. Get world. Can we get the world? Okay, we somehow need to find this object. I'm gonna quickly search how we could find this quickly. Alright, so there is a way to get an actor with a tag, and this, I think the tag one is better because we could have multiple one of them. So what I want to do is add a tag. How can I add tags? Never done this with tags actually. Let's see. Can we add tags here? Advanced. Or do we add tags by... We can also get them by class if I don't find it instantly. Okay, no, I don't find tags here at all. Or what? Toggle favorites, open, no. Okay, we're not going to go fancy here. We're just going to get them by class. So get actors of class. So what I want to do here basically in our game mode is, before we're basically going to call the set, I want to go to and get all actors of class, or get actor of class. Can we just do a simple one? And what we want to do here is a class. We want to have the time manager. And then we could just try to plug this into here, and this should hopefully work. I don't know if I might need to look around for that to maybe find a bit more suitable version of maybe also spawning. The ideal way would be to spawn the time manager actually here in the event begin play. I think this is a more reasonable thing because the time manager is quite static. Maybe we do need to set this up, but what you might want to do is basically create the time manager at the event begin play. It would be a bit more reasonable to do that. Okay, but no, the other thing is that we then need to link all these objects as runtime as well. So no, we're going to have a main time manager and we're going to try to find it. It's a bit more reasonable to do this like that. Okay, so this should solve the issue. So now if we would start, yeah, we automatically attach the time manager to the character and everything works. We can reverse the time, the train goes forward by, if I don't fall off, the train goes forward by default, and if I press my time reversal button, it turns around and goes nuts. And well, that is how simple things work. But the word is not simple, but that's the topic of a different video. In the next video we are going to implement or try to implement all of the other features we might not be able to. We might just do one example, we might have 1 or 2 more videos on the mini short series, but this one at least gives you a very basic idea of what you can do with that power here, the time power of Max Caulfield from Life is Strange. You can revert time. This is deterministic, so it was easy. But the next one are gonna be fancy and interesting. I'm gonna promise to you. So yeah, thank you for watching. See you in the next video, and you of course don't want to miss that next video, so you want to make sure to like the video. Okay, no, that has nothing to do with missing, but you should like anyways. So like the video and subscribe to the channel, and of course turn on the bell, it really helps. So thank you for watching, I hope you have a nice day, and stay tuned for the next Let's Create Max Caulfield's Power video in Unreal Engine 5. So have a nice day and bye!